Welcome everyone. This screen recording is related to demo for Informix online data migration tool that we introduced in 1410 XE1. So I'm going to show a demo to migrate the data from 1210 FC6 to the 1410 FC3 servers. So for this I'm using two Docker images. So let me log into my 1210 server. So this is my 1210 server, and in the second terminal I will log into my 1410 target server. Right, I have this 1410 server. Right now both servers don't have any databases running, but I did configure the storage pool. You can check the sysadmin database. Okay. So I did already configure the storage pool, and I did set up the trusted host configuration between them using remote server CFG. Right. This is my auth file, and another requirement is that I need to prepare my SQL host file for the groups in order for ER to work, enterprise replication to work. We need to configure groups for both source and target server. Is my source server group name, this is my target group name, this is my group ID 1 and 2. Right. So now let me install source demo database. So I'm also going to install another database. I'm going to create the testDB database with 3 tables. I'm going to create them, these tables in DBS1 and DBS2. I'm going to create those DB spaces using storage pool, and I'm going to insert some data. So now our source server is ready. Now you can see that our target server is empty. So right now our job is to migrate the data from source to the target. So we will use the cdr migrate server command. This is the command syntax. So you specify the source server name, target server name. Here we specify the server names, and do not specify the group names, although groups also should work fine. So you can either specify the server name or group name. And the phase, like I said, this tool itself is divided into multiple phases. So we have these 6 different phases. Define ER to define enterprise replication, add ER key to add ER key for the tables that doesn't have either primary key or unique index. And we also have a new one, add ripple check column. If you would like to add a ripple check column to make the enterprise replication check repair faster, you can have that as well. Create spaces will analyze the storage spaces required for the schema that you are migrating, and prepare the commands for them, and create schema data load. Like I said, it is the parallel data load. We create the tables as raw table, we disable all the indexes, then we load the data in parallel using I star queries, and at the end we create the referential integrity constraints. If you want a plain schema to be, if you don't want all that, you just want to replay the schema, you can use the create schema node data. And then the phase 5, create replicates. This is where we create the replicate definitions for all the tables involved in data migration. Right? Then at the end, the last phase, sync data phase, this is the phase where we repair the data, repair and push the existing data from source to the target. As soon as phase 5 is done, data immediately starts being replicated. Whatever the changes being happening on the source will be replicated to the target. Sync data phase is where we repair the existing data. So we copy the existing data from source to the target using enterprise replication. Right. So like I said, we also have a static data migration and dynamic data migration. So static phase involves phase 3 and phase 4, where we are assuming that there is no client activity at the source server. So in this case, all we have to do is the create storage spaces, replay the schema at the target, and load data. And dynamic phase requires all the phases. That includes enterprise replication, where here we assume that you have changes happening at the source server. By default, we print the commands to the as a script in a script format to standard out, and you can also redirect to a file using the file option. And if you specify execute option, then we execute the commands and do the parallel load and perform all the commands. Till you specify execute option, we are not going to make any changes to your source or target database. And you can specify if you want migrate one database at a time, you can use the database option. And if you want to migrate all the databases, then you don't specify the database name. And there are a few others. There's a parallel option, how many jobs you want to run in parallel. And there is the exclude option to exclude a specific set of tables. You can, so each table requires an exclude option. So you can have multiple exclude option for each table. Right? So let me quickly run the command -s. My source name is called source -t. My target name is also the target, and -p all, let's say all for now, and redirect to a file called let's say cdr.sh. Right? Like I said, we also print the commands in standard out, and we also copy those commands to the output file. So this is my script, right, that I generated. Like I said, one of the goal of this CDR migrate server is to implement best practices to migrate the data. So as part of that, we also recommend configuration changes as well. So we use right now we are recommending ERQ space to be at least 256 MB and suppress some certain warnings while replicating the data. So these two are related to the enterprise replication configuration. And the define ER phase, this is the second phase, the first phase where we are defining ER enterprise replication between the source and target server, right? And so like I said, here we are printing the commands, we are really not executing anything. And you can modify this and customize it for you. Or you can say, once you are satisfied the commands, you can rerun that same CDR migrate server with execute option. And that way you can take advantage of the parallel data load and parallel data synchronization. And the second phase is the add ER key. So here we looked at the source schema. We have two databases, source demo, test DB. And in source demo, we have 4 tables that require ER key. That means these 4 tables do not have either primary key or unique index. and the test DB as table 3 require ER key. So adding ER key is a slow alter. That means depending on the size of the table, this may take some time. So this is the only phase where you may require downtime at the to your client applications. So this is the create schema phase, right? So first we use the DB schema and extract schema from the source. You notice that there are a few new options we added to the DB schema here. -ER, no index. That means we skip all the indexes, primary key, foreign key, and unique constraints. And also we are seeing that create the tables as raw tables. So we are going to dump the schema to this temporary file. And then we create the database. So on the source demo is created in root DBS, which is not an ideal, but we will look at which database, which DB space the database exists, and we try to recreate the database in the exactly same format and using the same properties. And we use the DB import to replay the schema. We don't really use data load here. DB import is just used to replay the schema from the temporary file we created from the DB schema. And then kind of internally set the psort and procs to optimize the index builds. And so then there is subtasks begin. This is the parallel phase. To make it easy, we put these tags begin and end. And each job is marked with subscript 1 and 2 sequence number like that. So each of these can be parallelized. So if you run the execute option and you specify the parallel, so each of these subtasks are run in parallel. So basically we make sure the table is still a raw table, and the table still has the data on the target. We truncate the table. We set the triggers disabled. Then we use the select insert into select star from the source. As you can see that this script needs to be run at the target server. So we load the data from source to target, and then we enable the triggers when we convert the table back to the standard table. And we use the DB schema to dump just the indexes and constraint. This is the new option to dump just the indexes, primary key, unique key indexes, unique key constraints for this specific table. And we replay it. So we are building indexes also in parallel. And that's for one specific table called call type. So for job 2, so here we are dealing with the catalog table. So same thing is repeated for each table in the database. Right? So we have 10, 11 tables, 12, 13, 14. Tables. So that's a parallel phase. Then in phase 3, now we are dumping the referential constraint with this new option minus ref only. So it will only print the referential constraints. Now you can replay the referential constraints. So there is an issue here that we are planning to address in future versions. If you are online, now if your applications are making changes at the source, we really cannot enable referential constraint till we did the complete repair using enterprise replication. So ideally we have to defer this phase till the end of the data migration phase. So till we complete the, if you for online data migration, for offline data migration, this is perfectly fine. For online data migration, this step really has to be deferred till we repair the data using enterprise replication. Right, we do it for both stores demo as well as test DB. Now we are dealing with, so that was, sorry, this is schema phase 3 for that specific database called stores demo, right? So now same thing we repeat for the test DB. So we extract the schema for the test DB using no index and raw table option. And now since we have some storage, we need to create the DBS1 DB space, and we use the storage pool command for that. And we replay the schema using DB import. Then we create a subtask here for table 1 to load and build the indexes. We repeat that for table 2 and table 3. And at the end, we create the referential constraints here. So that completes the create schema phase. Now the create replicate phase. Right, these are the commands to create the replicate definitions. We make sure that queues are empty and define a grid definition, create a replicate set for each database, and define replication between source and target servers. Now, if you have a CDR columns, we create a timestamp conflict resolution. If you don't have a CDR column, CR calls, then we create a always apply conflict rule. Use always apply conflict rule. Those are terms related to the enterprise replication. And we start the replicates. We repeat this for each of the table that involved we want to migrate the data for. So as you can see, we created commands for each of the tables. So this can be used to even set up the enterprise replication. In fact, this is the command I use myself to set up ER between servers. Then, at the end, we create in a sync phase, sync data phase, right? And here we default, we use a check repair task. This is the data resynchronization task. You can also use the initial synchronization task. The difference is that initial sync assumes the target is empty, where we push all the data from source to the target. Resync assumes that you have data in the target, but you want to compare and repair the data. That's the difference between initial sync and resync. Right? This is the script, right? So if you run, you can directly run the script, or you can use the minus execute option and run it like that. So first, so if I let me phase all, I will use phase all, and also redirect to a file. This time I'll redirect output to a file. Oh, by the way, we can print commands for a specific phase. I can say define ER, so it's going to print commands for it, and I can say create spaces right? So we are creating commands for the create spaces phase and add ER key. So, and then create replicates, right? So each of these phase you can run individually as well. Now I'm going to use all and redirect the output to a file and use execute option. So I'm going to migrate the data. Now, so we are defining ER. ER requires DB space and SB space for the ER queues. We are creating them using the storage pool, both at the source and target servers. We added ER keys. Now we were doing the parallel data load, creating the schema and parallel data load. Now we completed that. Now we are defining the replicate definitions, and at the end we are resynchronizing the data. Right now it is done. With single command we are able to complete the data migration task. We look at our cdr.out. So here we will have all the commands that we ran internally. Notice that for each of these tasks, we have the begin timestamp when we started the subcommand, when did it end. So load finished at this time, we started index builds at this time, and index builds completed at this timestamp. So that way you can see what is the time taken for each of the individual jobs, and for data load as well as index builds. So now this is the replicate definitions phase. We create the replicate definitions, and at the end we synchronize the data. If you look at the ER list server, we have two servers defined with ER list replicate set. So we create a replicate set for each database. So this is the replicate set for stores demo. This is the replicate set for the test TB. And we also create a grid definition. That way, if you want to make any changes to alter the schema later on, ER will automatically take care of adding those new columns to the replicate definitions. Right? So if you rerun this command exactly, if I try to now do define ER, it will simply skip the phase because it knows that ER is already defined. If I try to run create replicates phase, create replicates. So nothing, since we already defined replicate definitions for all the tables. So if you just execute everything, even -exec option, we are simply going to skip all the phases because we already ran them, and at the end we still do the data resynchronization phase. Even the parallel data load phase, if some of the tables we are able to successfully load, but some of it, if we fail at some other rest of the tables, so if I rerun that parallel data load phase with create schema, we are going to skip them that for the tables we already completed the data load and resume from where we left off. Okay, this concludes the demo. Thank you very much for watching the demo. Hopefully this is helpful to you. Thank you. Bye.